Hi, everyone. Welcome to our webinar today called Using Temperature Detection Cameras to Fight COVID-19. My name is Matt Burtney, and I will be your moderator for today. And our discussion today is looking at temperature detection cameras manufactured by Provix. They're used to monitor for anyone entering a high traffic area that has an elevated temperature, which could be an early way to detect COVID-19. Before I introduce our host for today, I'd like to remind everyone that this presentation is being recorded and we'll be sending it to registrants via email after the webinar is finished. There will also be an opportunity for question and answers near the end of the webinar. So if you'd like more information about something mentioned during the webinar, you can use the chat function on GoToWebinar, and we'll address that during the Q&A portion of the webinar. I'd also like to remind you that we are still working remotely due to COVID-19. So we have our hosts are from way in the west coast of Canada and out east as well. So we are using personal Wi-Fi, and there may be some hiccups technically during the webinar. So we thank you very much for your patience as we get those things sorted out if they do happen. But without further ado, joining me today is Jonathan McCallum, the Market Segment Manager for Occupational Health and Industrial Hygiene at Levitt Safety, and Carly Winfield, the Technical Sales Consultant at Provix. So I will pass it over to you guys to get things started.
Thank you very much, Matt. Sorry, I was having a technical difficulty with my sound for a second, but thanks for the quick introduction, and thanks to everybody for participating today. As many of you work towards reopening and/or business continuity efforts, we're seeing temperature measurement become a factor in many return to work policies across the country for our customers. Over the last few months, we've worked with organizations that have supplied digital thermometers to their employees for home use, others that have issued non-contact infrared thermometers for use in various departments or locations of their business. And today we'll be discussing how thermal cameras are being introduced into the workplace. I'm very pleased to have Carly Winfield from Provix with us this afternoon. Carly will be leading the webinar this afternoon, and from there I'll hand it over.
Hi, everyone. Can you hear me now?
Yes.
Okay, perfect. Sorry about that. I'm not sure what happened. I just had a bit of a technical glitch, as Matt mentioned at the beginning. Just working from home right now. Sometimes these Bluetooth connections and everything, and internet Wi-Fi connections just don't support the video quality that you're trying to put out. So I'd like to introduce myself, or just tell a little bit more. I'm Carly Winfield. I'm a technical sales consultant with Provix, and I'm going to lead you through the presentation on the temperature detection cameras. So a little bit about who Provix is. So Provix was established in 1987. Our head office is based in New Lowell, Ontario, Canada, and we have a sales office and support installation office in Sudbury, Ontario, Canada as well. So essentially, our slogan is "Now I Can See." We provide video enhancement solutions such as cameras, LED lights, collision avoidance systems such as proximity detection. Essentially equipment-based solutions that enhance both safety and increase productivity. We're a video integration company, integrate many different types of camera systems, Canadian manufacturer of camera systems. We work with many different industries, from municipalities, utilities, mining companies, aggregates, construction, police, EMS, fire, hospitals, kind of everything. So we provide customized video solution, integrator with LED lights, and we have been providing thermal imaging cameras for a number of years. So we initially deployed thermal imaging cameras to see through things like dust and fog on a piece of mobile equipment, or to pick up a moose in nighttime areas. But essentially, we have altered these thermal imaging cameras to have alarm parameters to alarm when fever temperature occurs. So a little bit about the companies that Levitt and Provix are currently working with. So you may recognize some of those logos on there. That's just a very small list of the many different companies and industries that we are currently working with. And so we'll roll right into the temperature detection cameras. Essentially, with the outbreak of the pandemic, COVID-19, has come the necessity for many companies to screen their workers. So you may have come into contact into a place recently where you may have seen somebody scan your temperature, maybe with a manual IR thermometer, manual disposal thermometer, or you may have even seen one of these temperature detection cameras. But essentially, a lot of companies have decided that a safe way to go about business is to scan their employees or their visitors or their customers just to determine that they don't have a high fever before entering their workplace. So essentially, with a manual temperature detection, something like using an IR thermometer or a disposable thermometer is a close contact method. And of course, what we're trying to do in the future is, social distance and try to minimize that contact if it isn't needed. So those manual tests tend to put the person who's administering the test at risk. It can also be very, very timely, depending on the organization or even, customers going into a mall. Depending on the flow of traffic of people, it can really, really slow down the queues of people coming in. So something like a quick detecting temperature camera will reduce the time for people to flow through, the traffic flow through. So Provix has developed a non-contact line of cameras to detect temperatures quickly and accurately. Essentially, when somebody walks up to the camera or is within the camera range, it will detect their temperature within 1 second, and it will essentially determine whether they are above 37.3 degrees Celsius, which is determined fever temperature. It will identify whether they have that temperature, and then there will be an audible pass or fail and a green light or red light based on that temperature. So this will help prevent congregated entrances when a temperature detection is necessary or temperature screening is happening. So just to tell you a little bit about the different models, this one I like to call the one at a time or the single person temperature camera, in that it will only scan one person at a time or one person at a time. So this camera system is, if you think of a tablet or a larger cell phone, it's that. We've got a couple different sizes, but essentially it's a standalone system in that there's no requirement for network access. So it can be deployed anywhere. You could deploy it at the entrance of a mall, the entrance of an airport, the entrance of a manufacturing plant, and you don't need internet access. So if you have internet access, the camera has a LAN port on the side, and it can be connected to the network, which allows you to program the various features, such as that temperature alarm. You can edit it from 37.3 degrees to, say, 37 or 38, depending on what temperature you want to be alarmed when people are coming in. You can essentially, the network allows you to view any of what's being captured. So as a person would come into the range of the camera, if it was connected to a network, somebody would live view the scans that are being captured. And if you don't have network access, it's like a tablet or like a cell phone in that it has an internal memory. So it has the ability to store up to 10,000 scans. So 10,000 people coming through or 10,000 scans. It scans people in less than 1 second of them being within the range of the camera. And this camera detects their temperature when they're in the range of the camera. This camera range happens to be 0.8 to 1.3 feet. So if you think about, you have to walk up fairly close to the camera, but of course, with nobody needing to be there to monitor it, it will simply tell you pass, fail, and tell you what your temperature is on the screen. You don't have to worry about coming into close contact with anybody. So one of the most common questions is, how accurate are these cameras? So this one specifically is its detection accuracy or error range is plus or minus 0.3 degrees Celsius. And when an abnormal temperature or a high temperature occurs, it will trigger a voice alarm that will say that pass or fail, like I mentioned, the red light or green light. And that can be edited as well. We have both French and Spanish versions available currently. And you could, have it to say high temperature or low temperature, or, come through. You can essentially edit those pass or fail voice alarms to say whatever you'd like them to. And then there's also an abnormal temperature will trigger a relay alarm output, which I'll talk a little bit more as we get through here. So just to kind of show you a couple pictures, I always say a picture's worth 1,000 words. So these are images of it actually being deployed on a desk. So that standalone camera I'm talking about, we have options of a 5-inch or a 7-inch, and then just a couple different variations of mounts depending on where it is that you'd be looking to deploy this. So there's a desk mount option, as you can see there on the left. That one's pretty straightforward. It's got a little bit of a weighted base and would just be deployed on a desk. That's the 5-inch model, and that would require 110 volt power. So it does, you have to plug it in. And that can also be configured for, say, 24 volt power for a vehicle, or say 220 volt power as well for a different currency. So then there's a wall mount version on the side there, on the right-hand side. Pretty straightforward. Screw that one into the wall. So for the 7-inch camera, we've had a lot of requests for an employee gate or turnstile, because those are implemented at a lot of facilities. So there's the the gate or turnstile mount. It comes with a gate or turnstile bracket, and again requires that direct plug into power. This one has been our most popular supplied one so far. So it's a 7-inch, if you imagine, like I said, a tablet. And then this is just a weighted floor base. So it's a weighted base that you can set up, at any entrance, essentially anywhere. And then again, that would require the plug into power. So for when no power is available, or where you want to maybe have a little bit more portable option, we've developed this system, which is stored in a Pelican case, and it comes with a lithium-ion battery. So it's meant, the lithium-ion battery will power up the camera for 20 hours. And so we have a good example of this one is maybe a construction crew. We've supplied this to a construction company in that they are setting it up at the back of their pickup truck. When they start their shift in the morning, all of the employees would walk to the back of the truck. Obviously, they have no power, they have no network access, anything like that. It's just meant to be a portable solution. They pop it open, every employee walks up, can scan their temperature and confirm that they have not a high temperature to confirm and start work for the day. And so, as I mentioned, the camera has that internal memory to store up to 10,000 faces. So in an application like I just mentioned, it would store those faces if you store those scans of the people if you wanted to review that data afterwards. And so the battery charger is built into the case, and the system can be in use while charging. There's a LAN port for the cable and a charging port on the side of the case. So that one that we just talked about was the single person, in that it can only scan one person at a time. We also have some systems that will scan multiple people in that within the range of the camera. So this one is meant to be deployed anywhere that you'd like to monitor a high flow of traffic of people that would be, say, moving quickly, and that they would be not necessarily having to walk up themselves. So this would be more of an example at, say, an airport or a manufacturing facility, or, a security station where someone's looking to monitor a large amount of people at once. So this one will scan people within the range of 3 meters. So they have to be within 3 meters of the camera to be scanned, and it can scan 20 to 30 people at a time, of course, depending on whether they're within that 3-meter range. So you can see on the left-hand side that there's multiple people there, multiple temperatures. So essentially what happens is this system has to be connected to a laptop. So it's meant that somebody would be sitting there watching and confirming that nobody was coming through with a high temperature. And so what happens is, as multiple people flow through, you'll see the different temperatures kind of tagged or floating near each individual's head. So as they would walk through, that tag would follow them. And you can kind of see on the right-hand side here, there's a couple people with yellow tags or temperature tags, and they are yellow because they're all under that 37.3 degrees Celsius, where you can see the one individual there has a red tag on their head because they are 37.3 degrees Celsius, and you can even pick up their coffee at 41.7 degrees Celsius. But as you can see, it's very easy to determine who has a high temperature when there's many people flowing through, because that temperature would tag to that person when they're within range of the camera. And so with the excuse me, with the multi-person camera, essentially it comes stand-alone with that camera on a tripod that must be connected to a laptop, or it comes with a black body stabilizer calibrator unit. So without the black body stabilizer, so standalone, just the camera, its target error accuracy is plus or minus 0.3 degrees Celsius, which is the same as that single person camera I just mentioned. And then essentially, without the black body stabilizer, it's plus or minus 0.5 degrees Celsius. And in order to bring it down or bring it up to that 0.3 degrees Celsius, you actually have to add in the black body stabilizer. So essentially what that means is, because there's multiple people being scanned at one time, it has a harder time in capturing that many temperatures at one time. So this black body stabilizer helps stabilize the temperature levels and constantly calibrate the unit in that it will increase the accuracy to the plus or minus 0.3 degrees Celsius, which is the same as that single person camera. So it's just a tool that will automatically check the calibration of the thermal camera. And so yeah, you can essentially see that down at the bottom here, the one that's plus or minus 0.5 would only come with the camera, the software on the tripod, and then the one that's accurate to plus or minus 0.3 degrees Celsius would come with those three things, as well as that black body stabilizer to further increase that accuracy. So integrated video management software. So the camera is supplied with a video management software, and what this allows you to do is you can live view the scans that are captured on the camera, and this is where you would go in and adjust any of those alarm parameters. So it's preset to 37.3 degrees Celsius, but this is where you could edit it to say 37 degrees or 38 degrees or whatever temperature you want it to alarm at. This is where you would edit those voice commands. This is where you would extract any of the data. So essentially, when the scans are being captured, you can of course choose to delete these scans, but if you wanted to, you can actually extract these in an Excel format without the photos. So it's more of it's the data management side of it, and where you would adjust any of the settings for the camera. So both of the cameras have automated facial recognition, and so essentially this can be used or not used. So the cameras can be solely used as temperature detection devices to just simply tell you whether people have a high temperature or not, or they can be used a little more advanced. So the cameras do come with the software. The software would get downloaded onto your computer, and then once the camera is plugged in, you'd access the software, and you can choose to, if you were using it at a workplace and you had a existing database of photos of your employees. You could preload those in that when Carly walks through or John walks through, if those names and those photos are preloaded, it's going to know that, say, Carly's coming through with a normal temperature today. If you haven't entered any of that, it can be entered afterwards. So as the scans come through, you see that so-and-so is coming through, you are able to assign the name to that person. And then anytime that person would get scanned in the future, it would correlate all of the scans with that person. And so again, this doesn't need to be used. A lot of people do have concerns about privacy, and essentially it doesn't, these scans can be deleted and you don't need to put in any data. So it would have no idea to associate a certain scan with a person's name unless that data had been input by you. It doesn't have like a world database or anything like that. And so if the photos are preloaded into the database, then you can categorize them by whitelist, blacklist, and etc. And then data such as names, employee IDs, anything like that can be input by to organize by preferred parameters. And then you could extract that data if you wanted by, say, date, by employee, by ID number, whatever data you put in. And the facial recognition is not impeded by masks or beards. There also is a setting on the camera which is set to be disabled at the beginning, but you could go into the software and turn it on, in that it could alarm you if anybody was walking through not wearing a mask. So if you implemented a policy at your company, or you wanted to know that people were coming through and not wearing a mask, there's actually an option for it to say, please put on a mask. As well as that high temperature, normal temperature. So that can be added as well. And then, of course, a beard does not affect facial recognition, and it does not affect temperature as well. And so the temperature is actually taken from the forehead. So that's why things like masks or beards don't affect it at all. And so earlier I talked about with the single person camera, in that when the high temperature alarm was triggered, it would trigger the alarm, the voice alarm, but also a relay output. And so what that relay output is it's a wire harness, and it's a connection or an output that will activate based on the alarm settings. So we've got, of course, say that high temperature alarm set at 37.3 degrees Celsius. So anytime that it triggers an alarm, it would also trigger a relay. And this relay doesn't need to be connected to anything, but you have the option, of course, to connect it to something. And so this relay could be connected to something such as a push notification device, such as a access control system, a security system. It's integratable with a lot of different systems. The integrating feasibility is that this wire harness or relay output has contacts for normally open and normally closed on the wire harness. So if your existing system is integratable with that, which a lot of them are, then this system could also be used to, say, control or restrict access, or integrated with a push notification device where it would be set to, say, send an email alert once a high temperature was triggered. And so warranty on the camera, the first year is included. And then essentially we can discuss a second or third year warranty option if that's of interest. And just to kind of conclude here, essentially camera systems, these temperature detection camera systems are used to detect people's temperatures. They detect people's temperatures within 1 second of the person entering the camera range. So again, that single person camera range is 0.8 to 1.3 feet, and the multi-person camera range is 3 meters. So the cameras will have both a visual and an audible alarm if someone's temperature exceeds the normal preset temperature. Of course, you hope to increase your ROI, so return on investment, by reduced queues. So say you've got many employees coming in. I give the example of, say you've got 10 employees and you're using disposable temperature tests. That would be, 50 tests per day. If you're looking at a 5-day work schedule, that is going to be
Hi, Carly. Just checking to see if we still have you online here. I think a couple people lost a little bit of sound.
Oh, I am sorry. Can everyone hear me now?
That's perfect. Yeah.
Perfect. Sorry about that. I'm not sure where I cut off there. I was at the part about I just finished up the increased ROI, so maybe I'll go over that again. So essentially, if people are using, say, disposable temperature thermometers, so say you had 10 people a day coming in at, and I'm just giving a very generic example, but say tests were $5 each, and you had 10 employees, that's going to cost you around $50 a day for those tests. So if you were to multiply that by, say, 5 days a week, that'd be about $250. And if you multiply that by 10 weeks, that's about $2,500. So when you look at those costs, that would pay for a camera in itself right there for that example of a firm with 10 employees. If we look at examples of shopping malls or a storefront where you have customers coming in, if you're doing temperature screening, one, of course, you're putting those people at risk, so this will prevent that. And it will also speed things up. So when people are going through, essentially, you're going to speed things up because people aren't going to be waiting to be tested, because it will scan them within 1 second of them entering that camera. So it speeds up lines quite a bit. And then essentially the temperature detection cameras reduce the risk associated to that administering staff compared to the manual temperature screening. And overall, they're a quick deployable solution to be able to confirm that no one who has a high temperature is entering your facility or workplace or anything like that, anywhere. And so then we'll roll into questions.
Fantastic. All right. Well, first off, thank you very much, Carly. Before we hop into the questions, I'll just remind everyone who's been asking. We've had a few questions in the comments about getting a slide deck or the presentation sent to them. So we have recorded today's presentation, and we'll be emailing that out to everybody within the next 24 hours, and that will include the slide deck. So one of the questions that is coming up quite a bit is about how well they work in a Canadian winter, so their accuracy for that.
I should have mentioned in there, there's an operating temperature of the camera. So essentially, these cameras are designed for indoor use. They are not weatherproof. So Canadian winters, very good question. And obviously, the temperatures in Canada varies from, say, northern Alberta to, BC, for instance. So the operating temperatures of the cameras are 16 to 32 degrees Celsius. So with that being said, we have had some customers who have looked at deploying them in a outdoor application. But they would have to be protected from the elements under a tent or an awning, and the actual camera lens can't be obstructed. Because it's measuring temperature, you can't physically place anything in front of the lens, or it cannot accurately determine temperature. So in Canadian winter, at -20, no, it's not going to work because it's not within the operating range or operating temperature of that camera. However, in summer right now, it could definitely be deployed outside, provided that it's protected under some type of tent or some type of awning.
Perfect. And then in terms of accessibility, for instance, for people who there may be employees who are in wheelchairs, or different heights as well, is there an ability to change the position to take temperatures of a wide variety of heights?
So there is the ability to kind of adjust the kind of pivot the camera up or down. Essentially, there is not right now a amount that is height adjustable. Mind you, that's a very good consideration, and I'm sure that that's something that could be easily provided. So I guess long story short, essentially it's only going to be able to measure somebody who's at that height. So, it's not going to measure, I would say, someone who's 3 feet tall, for instance, a child, compared to someone who's 6 feet tall, it may have to be positioned at a different height.
Okay, perfect. And then in terms of the best practices, for instance, if someone just has a naturally higher body temperature, or there's been a couple of questions about women going through menopause, what's the best practices for not spending so much time trying to decipher whether the higher temperature may be from the person's body or from an infection or a virus like COVID-19?
Well, and again, every workplace is different. But what I've heard from some companies that what they're doing is they're posting a sign. So if someone did have an elevated temperature, there would be a sign on what to do. And it depends, I guess, where it was implemented. If it was a workplace where you had access to the data from an employee who was coming through, then you would be able to look at that data and see that that person has a typically elevated temperature. Of course, if you didn't or weren't storing that data, then if, for instance, somewhere like a mall where you don't know that person or anything like that, maybe a recommendation of something like a sign on what to do, maybe to go. And again, every place is different, so they're somewhat implementing their own policies. So I don't want to speak of what exactly the best practice is, but I would say some type of recommendation for and I think that essentially every place that's putting this in is putting something what to do if they do have a high temperature. Of course, in that single person one, people are walking up to it themselves. In that multi-person one, that would be where someone else is monitoring those people. So, maybe if somebody typically has a highly elevated temperature, and again, temperature screening is somewhat a new norm, but maybe people will start, carrying something that would indicate they had a high temperature. I will be honest, I haven't been asked about that as much, and the consideration about menopause is not something I had even thought about, and it is, obviously it's a real thing and it's happening. So I believe that once more companies start implementing these, then there will be more talk about what the best practices are. I just think because it's not necessarily a new technology, but a lot more being newly implemented, that we don't necessarily have all those answers yet.
Sure, and I'll add, Carly, that this is essentially one data point that contributes to an overall decision-making process. So a number of the organizations that we've been working with are using it as that. Many have developed a policy related to return to work, and likely this would be accompanied by a questionnaire or a next step if there was a temperature alarm. Generally we wouldn't see a decision being made immediately from that point, but it would trigger a next step, which possibly could, like Carly alluded to as well, might mean, speak to somebody or a further discussion on, have you traveled? Have you, similar questions to what you all might be experiencing if you walk into a local business, today. So it is one piece of information that would contribute to, a solid decision-making process.
Awesome, thanks guys. And we have a couple questions about the number of scans that the camera can hold. So you mentioned earlier that it was about 10,000 scans that the camera can hold. And can that information be saved or removed so you can continue to take readings? For instance, does it work like a DVR, where once the 10,000 images are stored, it keeps the most recent 10,000 and deletes the oldest?
Exactly, yes. So it's kind of like a DVR or like a constant loop. So if you were not extracting the data, then yes, once those 10,000 scans were reached, it would start to loop over, deleting the oldest and storing the newest. However, yes, you do have access, and that's so if you don't have network access when the camera is deployed, you can either bring a computer, or sorry, you could bring it to a place where there is network access, and then connect it to a laptop to extract that data. And that's what I was saying. You can actually extract that in an Excel spreadsheet so that you have access to that data in the future. But yes, it works exactly like the DVR constant loop.
Perfect. And we have time for a couple of more questions. Jonathan, from Levitt's standpoint, how could somebody, if they were interested in purchasing, go about doing that?
They can certainly reach out, even via question in this webinar in the question box, and we can certainly get in touch with any individual that would like to discuss the requirements a little bit further.
Fantastic. Okay, and in terms of field calibration, how often would that be required?
So for the all the cameras are calibrated by us upon manufacturing. The single person system does not need to be calibrated. The multi-person system also does not need to be. However, there is that option of that black body stabilizer, which essentially is a calibration tool that constantly checks it. So there isn't any need for maintenance of calibrating the units. However, there is that option to further increase that temperature accuracy on the multi-person one. So I don't want to confuse those things. So no maintenance required in terms of calibration. And the one thing else I should mention on the software side, there is no requirement for any licensing per year or anything like that. The software is included. And the only thing that will be required in the future is a firmware update. And a firmware update is the exact same thing as you would do on your cell phone, when you just install the update for free. And then you've got access to some of the new things. So for instance, when we first supplied the camera, we were supplying a lot of them in Canada, where it's obviously Celsius. And we had the request to supply it in Fahrenheit for users in the United States. So that was one of the updates that we've made. So some of those initial units that were purchased, they were able to do the firmware update in that they could change it from Celsius to Fahrenheit.
Fantastic. All right. Well, that is about the time we have at the moment. So we'd like to thank everybody who attended the webinar for today. Thank you, Carly and Jonathan, for being a part of this. And as we said before, we will be sending out a copy of today's webinar to everyone via email. In that email, you'll also see a opportunity to take a feedback form to let us know what you liked about the webinar and areas where we can always improve upon it. And so it's only a 4-question survey, and it really does mean a lot for us if you guys can fill that out. So again, Carly and Jonathan, thank you both so much for being here with us today.
Yes, and thank you everybody for attending as well.
Yes, thank you everyone for your time.
Take care.